Hello everyone. In this video we're going to go through math 2z3 child's math 2, the regular assignment. So alright, so this one they're just asking you to take the limit. You can see that for these two, when you take the limit, you'll get 0 in the denominator. Of course you can't have that, so you're going to do L'Hopital. This one's not necessary and you can just evaluate it as is. So when you evaluate this one, you'll just get 1, because you'll get pi over 4, and pi over 4 of tan is just 1 squared, is just 1 still. Now this one, on the other hand, when you take the derivative of the numerator and denominator separately, the denominator for both of them will be 1, but the numerator will get pi over 7 cos of, what is that, pi t over 7. And yeah, you're going to shove in 7 here. It'll cancel out. You'll get cos pi just equals negative pi over 7. For the second one, you'll get, what is it, 2t, in the numerator, and then you evaluate and you'll get 14. And that's it. My answers were negative pi over 7, 14, 1. I'm going to try and go through this as fast as possible because the due date is coming up. So this one, they're asking us for parametric equations of the tangent line to the curve. We know that the tangent line is the derivative. And so we're going to take the derivative at each point. And with that, we'll get x prime equals 2, y prime equals, where is that? Yeah, okay. Then we'll get t to the 4, z prime equals negative t2 times 4 over 1 plus t squared over 2. Now when we evaluate each of them at 2, we're going to get 16. This one, the x is just fine, and we're going to get negative 16 over 25 here. Now, our each equation will be represented as x equals x naught plus t times the direction vector, and these are all our direction vectors. And so we're just going to sub them in. So we're going to have x equals x naught at 2 as well. So x naught as 2 is just 4 plus 8, which is 12, plus 2 times t. Y will be 32 over 5, plus 16 times t. And z will be 4 over 5. Sorry, minus 16 over 25t. And she can tell from my answer that's correct. Awesome. So moving on. This one is one of the longer questions, but it's actually not that bad. I actually needed help with this question, so I can't say I got it first try. But you're literally just doing kind of like derivative rules here. So we're basically going to kind of expand each and every one of these to the inside. So first off, we're going to have r double prime at t times d by dt, r prime at t, cross product of r at t. And then this is going to be plus. So we're just doing product rule. So the first one, we applied it to the second. Now we're going to apply r triple prime at t times r prime at t. Cross product r at t. Okay, cool. Now, okay, let's keep going. So I already kind of noticed something a little bit off, but that's fine. Let's see who's calling me. Okay, so what we'll have then is we're just going to do product rule again. So we're going to have r double prime at t times r double prime at t cross product r at t plus r prime at t cross product r prime at t. Okay? And you'll realize something really quick here, that this will be 0, and then because you're going to multiply this in as well, it's going to be 0. And so we're just left with r triple prime at t times r prime at t cross r at t. Cool. And they're going to be 0 because you're crossing the same vector with itself, and then when you multiply this here, you're also going to be crossing the same vector with itself. Okay, cool. And that was C, which you can see is right here. Awesome. So then we're going to go to, damn, someone has a crazy car. Now we're going to move on to 4. So let's go in purple this time around. 4, we're asking us to find an R vector. You can kind of tell already you're going to be doing some integration because it's basically like, you know, R prime and then R, and we already seen that a bunch of times before. So let's do the double integral. So R prime at t will just equal 2 times sine 3t minus 8 over 9 cos 9t, and then plus t to the 5 over 5k. Remember, this is j and this is I. And then we have plus c. Sub in our first value, so we're going to have I plus j plus k equals, this is going to be 0, this one's going to be 0, and you're just going to have negative 8 over 9 j plus c. And so in this case, you're going to have c equals I plus 17 over 9j plus k. Okay, cool. And I'm going to sub that into the next integral that we do. Actually, let's just rewrite it right now. Prime at t equals 2 sine 3t I. I'll actually cut this and go back to it. Okay. Hello, everyone. So I just had to make a quick cut in this video. And now we're going to pick it back up from question number 4. So where we were was we were given these two initial conditions right here, and we're basically going to integrate until we get down to just R at t. Okay. So we did our first integration step. We subbed our R prime in. We have our c, and now I'm just going to write out fully what R prime at t is. Minus 8 over 9 cos 9t at j t to the 5 over 5k plus I plus 17 over 9j plus k. Awesome. And now we're going to integrate once more. And here we'll get R over t equals negative 2 over 3 cos 3t I minus 8 over 81 sine 9t j plus t to the 6 over 30 plus ti plus 17 over 9j plus tk plus c. Now, we're going to do the same thing in terms of subbing it in, but actually I'll add a second page here. Really wish I had like a shortcut for adding it, but it's okay. Okay, cool. So now we're going to sub in R at 0, which will leave us with our initial condition equals, the cos is just going to stay the same, negative 2 over 3 I. The sine will go away, the t to the 6 will go away, and all of these will go away to 0. So we're just going to be left with c. We're going to have c equals 5 over 3i plus k. And so finally, R at t will equal negative 2 over 3 cos 3t I minus 8 over 81 sine 9t j plus t to the 6 over 30 k plus t, oh, there we go, plus 17 over 9 tj plus ti plus tk plus 5 over 3i plus k. And just group all of these, group by component. And if you compare, that's the answer. Awesome. So here we're asked to find the length of the curve traced by the following vector function. So in this case, we have a formula that, will give us the correct solution, and that would be S equals, actually it's on our formula sheet. Yeah, I'd highly suggest printing out your formula sheet, by the way. So S equals the integral of a to t, the normal of VU du. So remember VU, V at u equals R at t prime, okay? So we could start off by taking the derivative of R at t. So R prime at t will equal 6e to the 6t cos 3t minus 3 sine 3t times e to the 6t, and this is the I component, plus 6e to the 6t times sine 3t plus 3 cos 3t times e to the 6t, this is our j component, plus 6e to the 6t times k. And now we have to get the normal of this. Sorry, there's this bug next to me. Okay, cool. So the normal would be square root of f at t squared plus g at t squared plus h at t squared. And all of these would represent like I, this would be j, this would be our k component. So what we can do is just take each of these separately, right? And then square them and then square root them. And you'll see why that's really important in a second. Awesome. So if we continue on, we will get for f at t squared will equal 6e, actually I'll just copy it. Okay, and this will just be squared. And for this one, if we take out the e to the 6t and square it, we'll get e to the 12t times 6 cos 3t minus 3 sine 3t. We could have kept it in there, but it really doesn't matter. It's just, it looks easier and it's easier to understand this way. So square the first, double the product of the two, and square the last. And in this case, we'll get 36 cos squared 3t minus 36 sine 3t cos 3t plus 9 sine squared 3t. Okay? And that's about all you can do right there. If we go to g at t squared equals e to the 12t. Remember, I'm basically just like, I'm not going to write the step, but I'm copying and pasting the same component we have right here, right? And I'm squaring it. So in this case, I already took out the e to the 12t, and then I have 6 sine 3t plus 3 cos 3t squared equals e to the 12t, 36 sine squared 3t plus 36 sine 3t cos 3t plus 9 cos squared 3t. Okay? Moving on to h at t, which is my favorite, we're just going to get 36 e to the 12t. Okay, so now, since we're going to have to add all of them regardless, right, then we could just add them before we include the bracket. And you'll notice a couple things. So this 36 sine 3t and cos 3t will cancel out. Well, I shouldn't say they're going to go to 0. They're just going to cancel out. Now, when I add this component and likewise this component and this component. I can just factor out the 9, right? And I'll have sine squared, cos squared, 3t, respectively. And so really, what I'm looking to do here for f at t squared plus g at t squared plus h at t squared, this will just equal 36 plus 9 plus 36. And remember, this e to the 12t is still there. And yeah, that's really about it. So just try and add it up yourself, and keep in mind that when you add up these two corresponding functions, that you're factoring out the 36, and you'll get a trig identity there. Okay, cool. So then if we go to root this, square root that, right? We got 72 plus 9, we got 81 e to the 12t, and this will equal 9e to the 6t, okay? And we are looking to do the integral of this. So if s equals the integral from 0 to 2 pi, and we have 9e to the 6t, we can bring the 9 out, and what we'll get is the 6 will go down, so we'll get 9 over 6 e to the 6t evaluated from 2 pi to 0. And so this will be 3 over 2 e to the 12 pi minus 3 over 2. And that is correct. Awesome. Okay, this question was fucked up. I actually didn't understand how the person who did this actually like came up with some of the shit. Like, I understand the length of the curve, but like I couldn't like rationalize this in my head. So let me walk you through the solution that I found online for this, and I'll try and explain what I understand from it. So a surface, let's do some highlighting. A surface x squared plus y squared intersects with the surface z equals 64 in a curve C. Find the length of the curve C. Okay? So we have basically just a circle here in 3 dimensions, and then we just have a plane that's at 64. Okay? Now, if we draw out our like diagram, okay, we could call this x, call this y, call this z. All right, and it's originating from 0, and I really hope it's not going to autocorrect, is it? All right, it's fine. And start up roughly the same thing here, and then we're going to draw an oval at the top, not like that. This is way harder than it looks. Okay, that's good enough. And we have our plane at 64. Okay. So that's the plane at 64. Now, if we look at the top-down view, which is what he's doing, all right, and to my understanding, this is where he's trying to get it from 3D to 2D, because he wants just a line, so he has to look in just 2D. This is what I understand so far. Let's draw a circle. Autocorrect this one though. Okay. So then he goes on to say, all right, so if we look at this top down, we have our, x, we have our negative x, our y, and our negative y, okay? And in this case, we have, we drew our circle, which models, yeah, okay. So if we're setting z equal to 64 in this case, then we have 64 equals x squared plus y squared, which in this case equals um, 64 minus x squared. And we root this, and yeah. So we know that up until this point we have a radius of 8. Yeah, a radius of 8 on both sides. So this part will be 8. This will be negative 8, 8, negative 8. All right, and it doesn't matter what quadrant we take. He took the top right quadrant, but I really don't think it matters which one. I think, actually, yeah. Actually, yeah, it does. Actually, no, it doesn't, because you could take either side. Yeah, you could take either side. For me understanding it, and for you guys, hopefully, we're going to take the top right side, because everything's positive there. So, then he goes to suggest that you have this formula, which I didn't find this online, equals the integral from 0 to 8, okay? This we remember from Calc 3, dy dx squared. But he puts a 4x here, and I don't know where that came from, to be honest. But he just did that. And then he goes on to do some funky u sub, and just for the sake of it, sorry, he does some trig sub, but just for the sake of you guys, I'm gonna write that down. But like, I don't know where he kind of got some of the stuff, and if someone can help me understand that, God bless you. 1 plus x squared over 64 minus x squared. Actually, I missed a step. X over root 64 minus x squared. Square that dx. Like, yeah, that's the model that he's... Okay, yeah, so if y equals that, you're looking for the derivative with respect to y. Actually, hold on a second. Yeah. 64 is x squared. It's a negative 1 over 2 times negative x. Negative 2x. Yeah, okay. This is going to cancel out. You're going to get negative x over 64 minus x squared root. Okay. All right, that makes sense. And then he plugs that in. This is where you get the negative here. Then he squares that. Okay, so now we can go back. All right, we'll have 4x, integral from 0 to 8. Root 1 plus, if we square everything now, we're going to get x squared over 64 minus x squared. And then, oh, then he did some weird shit. Then he did some weird shit here. All right. What the fuck? Okay, so I can only assume that at this point he goes to do something like, oh, okay, so he multiplies up, you get 64 minus x squared plus x squared, cancels, you're gonna get 64 minus x squared. Then in this case, you can factor out, actually you can't factor out shit. If you get 64 over 64 minus x squared, you could take the 8 out, for sure, dude. Oh, but that's what he did. Oh my god, I'm stupid. Okay, so he left 1 here, then he had 4x times 8, because you brought the 64 out. Okay, so then you get 32x, and then he represents his integral. Gotta make sure I keep writing the integral. From 1 over 8 squared minus x squared. I still, like, the only thing that's confusing me is this. Like, I don't know where he got that from. But yeah. Then he goes to... Alright, now the fuckery. Now the fuckery has started. Okay. Yeah, so you're left with 64 minus x squared. Oh, he evaluated that. Holy shit. Okay, yeah. So then he evaluates this, right? And then he did a U sub. He did a trig sub, which was like, dude, I'm not like you put this shit on test. I don't think I'm gonna get it, only because of this. The rest of it's fine, but like I don't think I could get it just because of that. So if someone could explain to me where the fuck you got that, mucho gracias. Um, so then we go on to write out our trig sub. Um, dx equals the inverse sine x over a. Cool. And so then we do, then we're finishing up final steps. So 4x, so 32x, and then sine inverse of x over 8, evaluate at 8 over 0. And so because the 0 will be just 0 as well, you're going to get, wow, he didn't even fucking evaluate that either. Holy shit. Okay. Let's actually do that then, because like 32x times inverse sine of 1 minus inverse sine of 0. And so, like, pretty sure I'm not tripping here, but yeah, okay. I gotta switch my thing to rads. Yeah, okay. So this one, as we said, goes away. And then 32x times pi over 2. And you're going to get 16x pi. And then fucking somehow the x just goes away. So like, I put in 16 pi because this is the same shit as my question. But I promise you, all the rest of the questions I can do perfectly fine. It's just this one is so fucking weird. Anyways, so more like a better question for me on my end. Question number 7. I think I got this on the second try, but this was one of the last questions I did. Yeah. So, find the velocity of the particle at time t. Find the position of the particle at time t. So I think I got it wrong the first time because of a algebraic error. But you're given acceleration as a function of time, and you want velocity of the particle, so you're going to take the derivative. I'm sure you guys figured that out before me, though. Okay, so if v at t equals a prime at t, oh, sorry, what am I talking about? No. When I wrote that down, I ended something's wrong. So v prime at t equals a at t, which means if we want v at t, then we have to take the integral of a at t. There we go, guys. That makes a lot more sense. And so a at t equals, what is it? 5i plus 4tk. I plus 4tk. Integral would be 5t plus, just simplify that, 2t squared times k plus c. This is v at t. And then we're going to have to use our sub. So v at 0 is 7i minus j. 7i minus j. And it's all at 0, so this just equals c. And so v at t equals 5t I plus 2t squared k plus 7i minus j. And then r at t equals 5 over 2t squared plus 2 over 3t cubed k plus 7ti minus tj plus c. Let's add another page. And then when you plug 0 in for this, we're going to get j plus 9k, j plus 9k, 0, 0, 0, 0. It's literally all 0. And so r at t equals 5 over 2 t squared I. I don't know how I keep forgetting that. There we go. Plus 2 over 3 t cubed k plus 7 ti minus tj plus j plus 9k. And if I check that, the first one, 5t plus 7. Then for j, we have -1. And then we have t squared. And yeah, so let's finish this up. We have number 8, which is a nice question. Number 8 is one of those questions where you're going to get used to. This is most definitely going to come on a test because it's 4 parts. You have to know what you're doing. Brings in some physics. Any good engineer would love to do this question. Okay, so let's do this in a different color. Actually, I'm feeling nice blue today. There we go. So, V naught equals 402 feet per second. We're assuming G equals 32 feet per second squared, and theta equals 60 degrees. And so, just remember that V at t, so you always start with A at t equals -g with the j vector, times the j vector. And you're integrating this, and you're saying V at t equals -gt j plus c. This is just r at t equals 0, and it really goes away, so you don't even have to worry about it. But the stupidest part that you realize is that this doesn't go away yet. So you can't assume this vector yet. That was a mistake I made. But what you can do is you can sub in this, and I honestly would just memorize this. You're going to sub in V naught times cos theta I plus V naught times sine theta j. And so subbing those values in, we're going to get 402 cos 60 degrees I plus 402 sine 60 degrees j. Cool. And this is -32 tj plus, if we evaluate those, for the cos, we'll get 1 over 2, and then for the sine, we'll get √3 over 2. And so kind of simplifying everything, plus 201i plus 201 √3j. Cool. And so if we reorganize this, we're going to get -3 over 2 tj plus 201 √3j plus 201i. Okay? And you know what? Let me do myself a favor here. And this is j. Okay? This is your y at t. This is your x at t. Right? So that's your A. That's your first. That's the first thing that you're going to enter. Oh, sorry, not yet. Sorry, guys. They're asking you for the parametric equations of the projectile's trajectory, and so this is v at t, but for the trajectory of it, you want r at t, which is just the integral of this. And so taking the integral, we're going to have -16 t squared plus 201 √3t j plus 201 ti. And sorry for that. This is your y at t. This is your x at t. Cool. So then we're looking for the maximum altitude. And at this point in time, maximum altitude has always been the derivative, because this is kind of like, if you're imagining a model's like this, the derivative will get you that point, which is the max altitude. And this is for when that equals 0. So if we take the derivative of y at t, we're going to get y at t prime equals negative 32t plus 201 root 3. And we're going to set this equal to 0 and solve for t. So t equals, what's it called? T would equal 201 root 3 over 32. Now you're going to sub this back into your y at t, and that'll get you, so like you're going to go y at t, where t equals 201 root 3 over 32, and this will get you your answer. I won't write this down because it's just like, oh, here you go, 1893.80, and if I even go to plug that back into my original equation, just for the sake of it, because I also want to double check, over 32 squared plus 201 root 3 times 201 root 3 over 32. There we go. So that is B. Your third one is going to be the range of the projectile. So here you're looking for when y at t equals 0. And that's because over the span of this projectile, y at t equals 0 at two spots. Its starting point and its end point, right? And you're looking for the range of it, so you want the distance traveled, which is d, right? Or r, depending on how you want to think of it. So let's add another page here. And I always like to draw these diagrams because it helps. Now, in this case, you're just looking for when y at t equals 0, and then solving for that t. So, there we go. Let's copy just this, actually. Okay. And we're going to solve for when this equals 0. And so you can get negative 16 factor out of t plus 201 root 3 equals 0. Remember, one solution is t equals 0. This is not solution, okay? Because that's just where it starts off. We want its next solution, which would be t equals 201 root 3 over 16, okay? Then you're going to do x at t, where t equals 201 root 3 over 16. And for me, this got me 4373.54 when we round it to the 2 decimal places. And the speed at impact is going to be the normal of v at this time t, which is the range, right? Sorry, the time for the farthest distance that it traveled. Okay? And so, how would you do this? Well, you know what v at t is, because we wrote it up over here, right? So we're going to just kind of plug t in and shove it into the normal vector. So let's do that. So in this case, we're going to do square root. The first one's just our I vector plus when we shove the other one, when we shove 16 in, then we're going to get negative 2 times 201 root 3 plus 201 root 3 squared. And this equals 402 on the dot. Awesome. So that is question number 8. Question number 7. Let's read this very quickly. Question number 7 was not that bad, actually. And I'll tell you guys why. Let me find, because I remember when I was doing this, I was like, holy shit, what's going on here? But then after a while, when I kind of thought to break it down, the problem with this question is that you have to follow through with your logic, and like that's what I guess we don't like, because it's like we don't have the sometimes we don't have the confidence to fully follow through with what we're thinking, but it's not that bad. So we said before that v naught equals v naught cos theta I plus v naught sine theta j. Okay, and so we know that g equals 9.8 this time around, and if I add another page here. Oh, where am I writing this? Sorry, looking at the. Let me grab this. There we go. So that's what we know that, all right? And if we go to construct our same v at t with like the same, format, we get negative 9.8 t j plus v naught. When you evaluate cos theta sine theta at 45 degrees, you're going to get root 2 over 2. And so we have root 2 over 2 here for the I vector, plus v naught root 2 over 2 for the j vector, right? If we go to combine these like we did last time, we're going to get v naught root 2 over 2 plus, minus 9.8 t, this is the j vector, plus v naught root 2 over 2, the I vector. Integrating this for r at t, we're going to get v naught root 2 over 2 times t minus 9.8 t squared over 2. It's also just 4.9, but I stopped doing that when I was in high school. Like putting it to 4.9, I just don't care anymore. All right, so that's what you're gonna get. You're gonna have plus c, but remember you don't have to write it here because r at 0 is just 0. And it's asking us for the initial speed. And we're given that our range is 3.18. So we want to get down to the range. Okay, so how do we get down to the range if we kind of work backwards here? So the range in the previous question made us solve for, what was it called? Sorry, this bug keeps flying around, it's annoying me. Okay, so the range in the previous question was along the lines of you needed to solve for y at t, which we did. We have y at t here, okay? And we needed x at t, so we could shove it into our equation. And what we wanted to do is we need to solve for our time of y at t when it equals 0. So if we go back to do that, y at t equals 0. And remember, we're going to have to do this so we can put it into our range equation, okay? So come back here. Now, we want v naught root t over 2 times t. And actually, I'm going to just factor it out from the beginning. Minus 9.8 t over 2 equals 0. So, of course, we don't have t equals 0. But when we, move it around a bit, we're going to get t equals v naught root 2 over 9.8. And you might just be able to see that from the 2's canceling out. Now, we're going to go to our x at t, where t is this. And what we'll get from that is v naught times root 2 over 2, right? Times v naught root 2 over 9.8, okay? And this is where it equals our max range at 318, right? So in this case, we're going to get this and this and this canceling out. And so we're just going to have v naught equals 318 times 9.8. There you go. That is your answer. Now, number 10 is two formulas. The first of which being t at t, which is on your formula sheet. I really wish they printed these at the beginning of the class, but can't have everything. And then the normal of r prime at t. And in this case, we're just going to go about finding our derivative first. We're given r at t, right? So r prime at t equals, let me zoom out a little bit. Okay, so it would be 10I plus 14TJ plus 0K. Awesome. We already know kind of where that's coming from already. Now we have the numerator. We need the normal. So of r prime at t equals square root of 10 squared plus 14t squared. Actually, it's just 14t all squared. There we go. And this will equal root 100 plus 196 t squared. And you can just put them over top of each other component-wise. So, you know, the 10, if I have to go with the 10 over this, 14t over that, and that's where you get this. And now we're looking for the simplified curvature of k at t. So, there's two equations present on our formula sheet. Let me find it again. Yeah, so we have k at t, or kappa at t, equals the normal of t prime at t over v at t. Okay, so we found t at t. We know that. And, you know, even this, we have it from this. So I guess what we could do is try and, yeah, I guess we could, let's just try, because I did this question via this equation the first time around, which was v at t with the cross product of a at t. It's actually not that bad when you do it, but let's solve this question a different way this time. So if we take t prime at t for each component, right, we're going to have the derivative of holy fuck. Like, I'm trying to piece my way through it, but like, yeah, I'm just not even going to waste you guys' time with that. Okay, so we're going to do it the other way, which is so much easier. So basically, you know how we took the derivative of r at t right here? We're going to go r prime over double prime at t equals 0I plus 14j plus 0k. Okay, so with that being said, if we go r prime at t times r double prime at t, which equals v at t cross with a at t, you're going to get I, j, k, 10, 14, 0, 0, 14, 0. Take the determinant of that, and then you're going to get k times 140. Okay, then you're going to normalize this, because you have to normalize it here. Okay, so if we normalize this, then we're just going to get root 140 squared, which is just 140. And so k at t equals 140k over 100 plus 196 t squared to the root 3 over 2. That's because in the formula, where is it? In the formula, you have v double prime at t, right? So sorry, v at t normalized, and when we did v at t normalized, we got just this, right? The only thing is, though, is that when you do the determinant, and for this one, it's v at t cubed. So you have 1 over 2 times 3 for the powers I'm talking about, so you're going to get 3 over 2. Sorry if that last one's a little bit laborious, but yeah, just do the second method, and I'll hopefully try and cut that out. But that's assignment number 2.